Hi, and welcome to Koos Dev Talk. Koos Dev Talk is a weekly series where the two of us,
Parsa.
and myself, Justin, talk about topics covering tech and dev. In this week's episode, we will be talking about some performance optimizations that we can make on the front end. And to start off, I'll leave it to Parsa.
Thanks, Justin. So, a few days ago, I was reading this blog post from Ken C. Dodds, one of the contributors to React Core, and he had this quote on his blog post saying, React is fast until it isn't. And he talks about the fact that React does all these optimizations and has all these great production builds that lower your package sizes and are pretty quick. But if you have massive amounts of data flowing through your front end and you're not looking at your performance and the things that you can do to improve the performance, it can lead to dramatic falls in your performance of React applications. So the main thing that we talk about in front-end development, and especially about performance, is dealing with things like long forms and rendering massive amounts of data. So if you think about it, because we have this hierarchy of components inside every React applications, and because the rendering of each of these components is based upon their parents, every time their one parent re-renders, it'll re-render everything. So the problem here is sometimes you don't want to re-render everything and you want to just re-render a single thing. But in most React applications, if we're not thinking about performance, we're making all these re-renders into our page, and when we have a lot of data, which in many production apps we do, that can cause many problems, and that can actually make your application slow.
Right, Parsa. So, kind of just re-summarizing what you just said, what we're really worried about when we're working with progressive web frameworks like React is managing the state of our application in a way that minimizes the amount of re-renders. That's kind of the biggest performance hit that a progressive web app could have. And another thing that we could do is also not only manage our state in a more efficient way, but also to improve the speed at which our front end is able to access some data, and specifically data that has already been requested before. And obviously this would be done in the form of caching, and one version of that being memoization. And so with that in mind, why don't we start with memoization? And Parsa, do you want to start with that?
Yeah, so one of the most common recipes that we have for making our React applications and any other front-end applications more performant is caching, and caching in the front end, which kind of ties into memoization. So what memoization is we're just looking at the change of data, and we're only actually re-rendering stuff when the data actually changes. It does come with a fallback, and it does come with a trade-off, and that is we're caching all these things in the memory, which means we're allocating much memory to our memoization. But it's always about weighing those options and seeing which one is actually affecting the performance more.
Yeah, and so even when you're just thinking at like hardware level, if we have lots of memory and we can trade off some computations from the CPU and then just use memory, which is what memoization does, we can generally deliver a better product in terms of the balance between using slightly more memory to greatly decrease the runtime of the application. And I think relevant to React applications, or again, progressive web apps in general, we're using memoization not to memoize the typical, like a dynamic programming problem where, in a recursive function, we would be using memoization to save states in the recursive tree so that we don't have to make calls. Like if we're using Fibonacci as an example, if we're trying to call f of 3, we don't want to have to call f of 2 twice. And so that's kind of how memoization works when it's dealing with a recursive function. However, in this case, for a progressive web app, we're trying to memoize the state. And by memoizing the state, we don't React doesn't have to re-render the whole component when we have the state being memoized. And that's important because if we're trying to make an expensive call, like to your backend web server, by memoizing the state, and then let's say the user's trying to just do something on the local side only, like changing the theme color of the web app. By doing that, we don't have to recall to the web server for the same data that hasn't been changed in any meaningful way, or any way at all, actually. And it's able to just save that particular data and then show it back to the user without making a second call. And so that saves not only performance in terms of runtime, but also saves a API request back to your web server. So it's actually just more efficient in general, which is obviously in the interests of all devs. And we'll move on to the next one, which is going to be virtualization.
Yeah, so virtualization kind of ties back into memoization. We're still talking about rendering stuff to the page and deciding when to render them. But when we talk about virtualization, and it's specifically what we're doing is that we're actually rendering the things that the user is actually seeing on the page. So imagine you have this long list of cities that you have in your application, and the user is supposed to just scroll through them and find the ones that they like, or find the one that they live in. And well, city might not be a good example because you can always have like a search bar or something for it. But when you have big lists of things and you want to render them to the page, you probably have a scroll bar somewhere that the user uses to go through this content. And when we use virtualization, we use that scrolling mechanism to recognize where the user is and what data they are actually seeing on the page. So this actually helps us not have extra elements on the page and just show things to the user as they're needed.
So kind of like if we're scrolling down our typical timeline for a social media platform, not all posts that a user could potentially see are, actually rendered to the front end. Maybe it's just 25 or 50 or whatever the case may be. But certainly for an infinite scrolling timeline like Instagram or Facebook, only the posts are rendered on demand. And so that's kind of what you're talking about.
Yes, but I also want to bring this note up that virtualization is not lazy loading. So I wanted to talk about lazy loading next, but I guess it'll just be a good segue to lazy loading. So with Instagram, what infinite scrolling is as we go through the content, it'll load more stuff to our page, which is what lazy loading is. So it'll just load the content that you need to see. With virtualization, you're actually only rendering the things you need to see. So the difference here is virtualization, you have the data, you're just not rendering into the page for performance reasons. With lazy loading, you don't have the data. You still have to go to the web server and receive the new data, and then maybe use virtualization to show it, or maybe just render into the page right away.
Right, but you're probably using a combination of these two things. Well, especially when you have low screen real estate, right? So if the API call to the backend loads, say, 100 posts at a time, your screen is still not going to show 100 posts. So you could potentially use a combination of that to render only 25 objects out of the 100, and then you're kind of using virtualization virtualization and lazy loading at the same time.
Yes, absolutely.
Another thing we could talk about is just kind of, this is all state management, but kind of going to Redux, so state managing with a state management system.
Yeah, so this one might be a little controversial because I've talked to many people who think Redux is just a waste of time for the user and is a waste of time for the developer to set up because obviously it has all these overhead and all these boilerplate code that you have to put in your code, and it has a pretty big package size as well. So it's a bit controversial, but I'm gonna present my reasons for having Redux and one of the things that we can do to improve performance. So what Redux does is it breaks down your logic into a separated part. So if you've used Redux chunks, that kind of takes away the fact that it helps you make API calls without actually having to deal with it in your React application. So that's one of the things that Redux does that you can do it yourself too, but it kind of gives you a better workflow where you make the API call, all the data is injected into your Redux store where all the data is saved, and your components are just reading from the Redux store. So it makes this waterfall kind of workflow for the data to come from the server, go into the store, and go into the component. Another thing is some people just say they don't need Redux. All they can do is just make a flux pattern in the React applications. And for those of you who don't know what flux pattern is what Redux does. So you have a store type of thing, and you have your subscription mechanism, which looks at that store and renders stuff to the page. So with React hooks, you don't need Redux necessarily. You can just use reducer in combination with use effect and use context, and you can simulate what Redux does for you. But what Redux does that you probably can't do it yourself, or it's going to take a long time for you to build it out, is it gives you a query mechanism. So instead of every time looking at the entire store and getting all the data just to take out a little piece of the data that you want, with Redux you can query your store and only look at the things that you want to look at, and this increases your performance by a good measure. So here are my reasons for using Redux. It'll give you a better workflow. It'll stop you from refetching stuff from the server with that workflow, and it'll also give you a way to actually look at the data that you have instead of looking at all of your data and just taking out a piece.
Yeah, and I think even on the Redux docs, it says not to use Redux until you need to, right? Or at least that's what the original creator of the library said. So, you know, it's definitely a lot of code and a lot of extra effort to have set up to do some state management for you. But I think this is actually a great segue to something else when we're to talk about when it comes to efficiency, and that's the transfer of state from the web server to the front end. So a lot of applications use REST. You make a request, the server returns some sort of JSON object, and then it has a bunch of state and data inside. And it often, especially when we're working with larger, more complex APIs, it will come with a big object with lots of nesting inside and lots of stuff that you might not actually want. Often it will have lots of stuff that you don't actually want. And so the thought is that that's kind of wasteful because, well, what if you had a system that you could just use to query for the data, and then the server sends you only exactly what you needed plus the metadata that you need for the transfer between the web server to the front end. And so that's kind of where GraphQL comes in. And, we're just talking about having a store and accessing, fragments of your data instead of the whole thing. And GraphQL is able to do kind of all of these things. So what GraphQL does is it's a query language. Your front end will query in a kind of SQL-like way. And so maybe for the front end, we want all the movies by title, and we want to select title, year, the IMDb ID, and a image link for the poster of the movie. And so we only want 4 things. With GraphQL, we're able to do that even if the web server is able to send like many things. Like there's many things associated with the movie, like genre, user rating, and critic reviews, and the language supported, and all this type of stuff. With a REST server, you probably get all of those all at once. Like you in the REST server, you say get movie by ID, or maybe there's a search function and you're getting the movie by the search. But you're going to get all this data instead of just the 4 things that you actually want. And maybe from a app perspective, maybe what the page we're looking at right now is just the page showcasing bunch of movies with thumbnails for the posters, and we aren't going to show detailed data to the user right there, not until they click it. And so maybe when we click the image, we can get to a page where there's actual details, and then we can go get the rest of the data. And so in this way, we saved a lot, because think about how in the situation where we queried, say there's 100 movies, we have 100 objects with genre and the amount of time the movie takes to play, and the directors and actors. Maybe we don't want any of that stuff, and the user doesn't want any of that stuff. The user's only going to browse at things that interest them, like 3 or 4 things or something like that. And maybe your web server has a route just to send you summarized data instead of the full thing. But if it didn't, you'd have all this data that's just being useless, like it's not doing anything. And so the more that I read up on GraphQL and work with GraphQL, I can kind of see how it's a really interesting technology and could be, really how we should be using or building web apps in the future. And Parsa, do you have any lingering thoughts, last thoughts?
Yeah, so lastly, I just want to mention why we talk about performance and why it's important. If we actually take the time to measure our performance and aspire to improve it, it'll benefit us, benefit our users, and it'll benefit everyone around us to deliver this content more efficiently and faster.
And with that, I'll leave it to Parsa to do our normal sign-off.
All right, thanks everyone for watching the 4th episode of Koos Step Talk on React and performance. Please make sure you subscribe and like our videos on YouTube, and we'll see you next time.
Yeah, see you next time.